Welcome to section 9.11. This is the 80-second session of the CISSP exam prep series. In this session, we'll compare edge and fog computing. We'll answer 4 questions. What is edge computing, and why move processing outward? How does edge fit the long arc of computing history? What is fog computing, and where does it put the brains? And how do edge and fog differ side by side? Why does this matter beyond the exam? Because where you place processing shapes both speed and security. Picture a self-driving car deciding to brake, a chain of stores tracking shelf sensors, and a video call that must stay smooth. Each one wins or loses on where the computing happens. When you can reason about that placement, you design systems that stay fast without shipping every byte to a distant data center. So what is edge computing, and why move processing outward? Edge computing is a design where data and compute sit as close together as possible. Instead of hauling data to a central brain, each device does its own thinking right where it stands. That cuts latency and saves bandwidth because the work happens near the source. Think of a smart camera that decides on its own whether it saw a person rather than streaming every frame away for a verdict. How does edge fit the long arc of computing history? It is the newest turn in a long swing between central and local. First came mainframes, where everything ran on one core machine and thin clients just displayed the results. Then client-server pushed real work out to endpoints. Then virtualization gave us cloud, pulling computing back to remote data centers. Edge completes the loop. Control stays central, but the actual execution moves back out to the edge, right next to the user. What is fog computing, and where does it put the brains? Fog computing gathers data from many scattered sensors and devices, then hands it to a central point for processing. That processing point sits inside the local network, not out in a far data center. So the intelligence is pooled in the local network, chewing through everything the scattered devices report. Picture a warehouse where hundreds of sensors feed one nearby server that makes sense of the whole floor at once. So how do edge and fog differ side by side? The split is simply where the thinking happens. In edge computing, each distributed device processes its own data on the spot. In fog computing, the distributed devices only collect, and a central node in the local network does the processing. Both often lean on the same building blocks, like microcontrollers, embedded devices, and connected sensors. Edge is many small brains at the ends. Fog is one shared brain in the middle. So let's bring it together. Edge computing places compute right next to the data to cut latency and save bandwidth, with each device thinking for itself. It is the latest swing in the arc from mainframe to client-server to cloud, returning execution to the edge while control stays central. Fog computing instead collects from scattered devices and processes in one spot inside the local network. The clean contrast is distributed processing at the edge versus centralized processing in the fog. Choose the placement that fits your latency, bandwidth, and trust needs. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.